Hello everyone. So in this video, I will be demonstrating the application of controlling cylinder by integrating it with the use of relay devices and PLC, which is a stamping device. And I will be using fluid sim for simulation. So as you can see in this picture, we have here the three cylinders that operates in the whole system. So we have here the cylinder 1, which moves a rectangular block out of the magazine. We have here the cylinder 2, which stamps the block, and the cylinder 3 ejects the block to the container. So for the electropneumatic wiring, you can see here the three cylinders, which are double acting cylinder. We also have here the 5 two-way valves that are controlling the force or the direction of the airflow to the cylinders, in which all valves are connected with the same air supply. Each valve is connected with a solenoid that whenever it is triggered, the valve shifts position. Also, each cylinder is associated with two sensors affixed at the beginning and at the end of the cylinder. So moving on to the I/O wiring, as you can see in this diagram, we have here the logic module wherein output and input devices are connected. Since we have two sensors for each cylinder and we have three cylinders, a total of 6 sensors will be connected to the input of the logic module, and we will be having 3 solenoid valves connected to the output of the logic module. So moving on to the I/O assignment, PB1 is a normally open momentary switch that denotes the start of the system operation and has an address of I1. So S1A, S1B, S2A, S2B, S3A, and S3B are all sensors which has an address of I2, I3, I4, I5, I6, and I7 respectively. So Sol1, Sol2, and Sol3 are all valve solenoids which has an address of Q1, Q2, and Q3. Move to the program. So focusing on the logic module, it consists of several blocks that utilizes the concept of logical operation, which includes the AND block, the NOT block, and latching components, specifically an SR latch. So the AND block is a component that utilizes the concept of an AND operation, where two inputs must be high in order to generate a high output, or in logic 1. So the NOT block functions as an inverter in which high input generates a low output while low input generates a high output. So the SR latch is a component which is dependent to the logical state of both S and R inputs. As you can notice, the sensors are connected to the input side while the solenoid valves are connected to the other side. That whenever PB1 is pressed, the solenoid will be energized, resulting to the shifting of the valves. So here you can see that all valves are initially retracted, which corresponds to S1A, S2A, S3A being at logic 1. So the push button is connected to I1 of the logic module, in which it will give high output whenever it is pressed. So pressing the push button will energize the solenoid, thus it will make the valve shift position, and the piston inside inside cylinder 1 will extend. So the piston will then get back to its original position after extending due to the string attached to the valve. So as the piston extends, S1B will be triggered, hence S1A will be at logic 0, while S1B will be at logic 1. So in that case, it will trigger the second solenoid, which is connected to the second bulb, which then extend cylinder 2. So the extending of cylinder 2 will affect cylinder 3 immediately after extending and retracting of the cylinder 2. So it can be illustrated by running the program.